pleased to know the presentation is very short. We only have 15 minutes, so we'll race through. There's only 2 slides. In fact, they're both just pictures. There's no words. So we'll try and go quickly through it. My own history with CAN-ductor was with Sika Point Energy, and we were one of the first to use CAN-ductor on the UK continental shelf. We had this in 2 phases, that's why there's 2 slides. So the first phase is this one was on the Cambo appraisal well that we drilled in 2018. It's in 1,100 meters of water in the west of Shetland, in the Faroe Shetland Channel. So it's quite deep, difficult conditions. And when we drilled an appraisal well, we had the idea that instead of simply appraisal well to appraise the reservoir, the formation, we could appraise the techniques and the technologies that we would be able to use to develop the field. So this was a slightly different take on appraisal, and CAN-ductor was one of the primary ones. We did a couple of other things as well, but this was probably the most important. I think everyone in the room is familiar with the technology, and the introductory video was fantastic as well. So I can say a little bit things that I'm going to concentrate on what we did that's different, that did differently. And I suppose with the 2 slides, the second slide is about how we plan to use CAN-ductor in the Cambo development. So it's a journey, if you like. So the left-hand side is the a slice through our CAN-ductor, and you'll see there's one thing that's probably different from most of the others. It has we were able to drill about 830 meters below the mud line, riserless. So we set the 30-inch by 36-inch low-pressure housing, of course, with the 30-inch extension joint, and then we swedged down within the can to a 24-inch diameter guide pipe, and we're able to drill out, allowed us to drill out in 17.5-inch hole. So we didn't require. So in our case, CAN-ductor replaced both the 30-inch and the 20-inch casing in a deep water well setting. So it's a little bit different. Of course, you'll see in the next slide, but that allowed us to set 13 3/8 down at 830 meters below the mud line, and then above this swedge, we swedged back. We came back to the 20-inch and the high pressure housing. So when we ran the in combination with the 13 3/8, and then cemented right back to the can top. So at that stage, the well integrity is completely established. Another thing that we did, that we documented quite well, was the on the bottom right-hand corner. So the drill-out procedure was very well considered, and something we would recommend to everyone. So to drill out wash through the can and then drill out with lower parameters and stage up once you get to the bottom of the can. The other things that are happening in these slides, we used, I'm just sharing some things that we did that may be relevant. Difficult west of Shetland, we did this installation in February, and we're going to have some pretty horrendous metocean conditions. So we used this crane master. I don't know if you're familiar with this one. So it's a hydraulic motion compensating device that we ran it gave us a little bit, extended our weather window a little bit. So we were able to operate with about a 4-meter maximum sea state, which would have been less. It would have been about 3.5 without that crane master. So that's a kind of an interesting option that we wouldn't normally have. This photo is the view. We crawled in underneath and we looked up inside the can, and that's where the 30-inch, the 44-inch guide pipe steps down to the 30-inch extension joint, and then the guide pipe below it. Drilling riserless, we ended up with a massive cuttings pile, as you can see there, but we were able to wash that away within about an hour and a half, just using the ROV pump on the rig. So it didn't prove to be a problem at all. On to the next slide. So as I said, it's an evolution. So that was using it in the appraisal well allowed us to have the building block for using CAN-ductor as the basis for our field development. And you can see it was the first stage of CAN integrator. So we integrated the PGBs onto the cans, and you can see that's the design. And it has, we also, for the development, the plan is to orient the cans, and we can do that plus or minus 3 degrees. So something that we perhaps, a feature of CAN-ductor that we don't always take advantage of is the fact that we can put them in a specific orientation. And of course, orienting the can orients the PGB, and that we use the coarse and fine alignment to orient the BOP, and the BOP pin to orient the tubing hanger, and then the tubing hanger and those guideposts to orient the trees. So the plan was to suspend all the wells at the tubing hanger and then run the trees on wire. The PGBs look quite small. They're part of the Baker Hughes Aptara system, for anyone who's familiar with that, which is a deep water vertical tree, but in a smaller format. So it's on a 10-foot, the tree base is on a 10-foot frame rather than a 14-foot frame as a traditional deep water vertical tree. Hopefully the most interesting thing about this slide is this is one of our drill centres in Cambo, and you see the manifold in the middle and the connections back to the FPSO. But each of these is a CAN-ductor, so that this was a 6-slot manifold. The flexibility that you get from designing so using CAN-ductor as the main building block for field development planning is the flexibility that's built in. So we didn't have to, we were actually only going to drill 4 wells at this drill centre in the first phase of the development. So, but you can add wells, and gives you lots of flexibility. You'll see each well coming back has the flow line, which is oriented using the system we talked about, back to the manifold, and we had gas lift and control lines as well, are all mapped in, all with flexibles. Much cheaper and more flexible, and very well suited to phase development. Also very well suited to batch drilling. So we wouldn't, we were going to drill all the wells to and have the 13/3/8 set and the high pressure housing installed before we ran the BOP the first time, and then it was basically batching and hopping between the wells. Well design itself, not necessarily only because of CAN-ductor, but I find that once we start to think about CAN-ductor, it frees us up in a way in well design. And this was on the right hand side, just a simple sketch through one of the wells for the well geometry. You see the can, and then we have inside the 40-inch guide pipe, 44-inch guide pipe, then the 30 by 36-inch swedge down to the 26-inch guide pipe, and then inside that the 13 3/8 coming back to the 20-inch, and then we built a horizontal and run in 12 1/4 and run a cement 9 5/8, and then 8.5-inch hole and 7-inch lower completion. So it means that the wells are very simple. It's really a 2 casing string design. So the actual time to deliver these wells becomes very compressed, and which is something we like. So reducing scope is always one of the main objectives, especially in deep water development drilling. So it became a very powerful tool for us. We did a few other things, again, talking about our own experience. So we used at the diagram at the top, we used the data that we obtained from the appraisal run to redesign the can, and Wolfgang and the engineering team did a fabulous job of mapping all the stresses in the can based on the forces that we'd experienced in installing the first can, and we were able to reduce the weight, and some of the plating was reduced slightly. So we came from something like 120 tons. So the cans are 17.5 meters tall. At that time, they were the tallest ones that we built. And we were able to reduce the weight from about 125 tons to 112 tons, I think it was. Maybe it doesn't sound that significant, but it all helps. We did take into account as well, so at the end of field development, at the cessation of production, we saw some quite significant advantages in P&A for the Cambo wells also. So, there's a single cut with this well design at the base of the can, to cut through the 9.5/8 and 13 3/8, and then pump the can out using the ROV to get it moving, and then we'd come back with a vessel to recover the cans. So it means the deep water P&A and leaving the clear seabed can be quite onerous. So this was another advantage for us. So I think one thing I wanted to explain was I think it takes us quite a long way from, we originally started thinking of CAN-ductor as simply a better, quicker, better, safer, cheaper, lower CO2 emissions way to construct top hole, which is true. But I guess we've taken it to really another level when it becomes a building block for your entire field development. It opens up, and the savings, instead of being in hundreds of thousands and millions, is maybe tens and hundreds of millions. We have the very comparable, Cambo's right next door to Rosebank, which they've elected at this stage not to use this system. And I know we were a partner, so I know that their subsea costs for Rosebank are 3 times higher than for Cambo, even though the number of wells is very similar. So just to give an idea, so the potential savings can be enormous by taking the technology and pushing it, using it to its full advantage. And we're ready, we're very happy at Neodrill to work with you and to try to extract the maximum value from the well design and from the subsea scope as well. And I think I'm getting the signal that I'm out of time. Maybe time for one question?
Absolutely, questions?
Okay.
Then I saw you've been you worked on this project, and we all know that Cambo has been put on hold, but
yes,
potentially coming back, and you have plenty of time to think about this. And if you were to do it again, would you see that there are opportunities for even more simplifications or optimizations leveraging this? Could you say something about that?
It's a great question. Anyone might think I'd planted that question. It's such a good question, but I didn't. But it was I think the one thing that we would do differently is we use the PGB from Baker Hughes to match the Aptara system, but we don't see any reason why we couldn't put all that PGB functionality built into the CAN top. So that would be the next stage of that process, the next stage of evolution, if you like. So I think that would be one thing. There may be some other things as well when we come down to it, but that's probably the key development going forward for that project. The other thing I was just going to say was I'm really excited about being here today, and I'm really looking forward. This is our story of how we used CAN-ductor for the appraisal well and then planned it for the development wells, and I'm really excited about hearing how all the other companies are using CAN-ductor and evolving and getting the best value, because I think hopefully there may be some other ideas that we didn't incorporate that we could use in the future. And that was all.
Thank you so much. Give a round of applause.